we'll go ahead and get started, and a couple of people might also still join in. My name is Val Blair. I am here. I work and produce the Wisconsin Science Festival, and we're so glad to have you here for one of our virtual field trips. We have some of the folks from the core repository, and we're going to get to tour that today, so that's pretty cool. So start thinking about all the questions that you might have about rocks and minerals that are found in Wisconsin. Carsyn and Anna are here from the Wisconsin Geological and Natural History Survey. So the way that you can ask questions of Carsyn and Anna is to use the Q&A feature. So if you type your questions into the Q&A feature, then I will help get those questions to Carsyn and Anna. But first, before we get to your questions, go ahead and start. I'll let Carsyn and Anna introduce themselves a little bit and say how they got into science, and then we'll get to those questions. All right, take it away.
Cool. Thanks, Val. So I'm Carsyn Ames. I am the curator for the Wisconsin Geological and Natural History Survey, which is a fancy way to say I'm in charge of keeping all this stuff behind me organized. So I'm kind of like a librarian for geology. I grew up in South Carolina, and I didn't really know that I wanted to be a geologist when I was a kid. I was signing up for my college classes, and I thought geology would be really fun, and you would get to go outside, which I was like, that sounds really cool. And then I only had to take 2 math classes. So I said, all right, sign me up. So that's kind of how I got into geology, and I ended up really, really liking it. I liked it so much that after I finished college, I went to some more college. So I did 2 more years of school, and I got my master's degree. That was at the University of Iowa. And then when I graduated there, I found this job, and I've been here for 5.5 years now. So this is pretty much my only professional geology experience, is being geology librarian. I know Anna has done a lot more and a lot more cool stuff.
Oh, well, I don't know about cooler, but I can give a background. So I am a hydrogeologist at the Wisconsin Geological Survey, and that means I study groundwater. So groundwater is the water that has seeped into the ground and is flowing in the pore spaces in between, like sand grains, in sand and gravel, and in sandstone. And most of us use it for drinking water. And it's also really important for like streams and lakes and their ecology. And so what I do, well, let me back up. So how did I get into studying groundwater? I kind of like Carsyn, when I was in college, I didn't know that I wanted to be a geologist. And the first geology class I took, we immediately went and did a field trip in the Black Hills. And I thought, this is what I want to do. But I actually really liked doing the math. I wanted to take more math classes. So I did geological engineering for my degree. And it took me a little while to go from engineering into more of the groundwater focus. So out of college, I did some consulting work for an engineering firm and also for a water resources consulting firm. And that was really great experience to figure out a lot of applied work that, what are people doing? What data are they using to make decisions about groundwater and other water resources? And then from there, I came here to the survey. I worked at the survey for a few years. And then I also worked at the Department of Natural Resources. And what I did there was help make decisions about new groundwater wells that are being drilled for people to either drink from or to use for irrigation or industry. And you have to have an understanding of how the groundwater system works and what impacts pumping will have to make those decisions. So now I'm back here at the survey. I'm really, it's a really fun job, and I'm looking forward to your questions.
Awesome. I'll just interrupt again a little bit. We have the school from Eagle River has joined us, which is awesome. Welcome. Welcome to the call. This virtual field trip's a part of the Wisconsin Science Festival. So Carsyn and Anna got a little chance to introduce themselves. And now I'll let them show you around a little bit. But if you have any questions about what you're seeing or about rocks or about geology or what it's like to be a librarian for geology, put those questions in the Q&A, and then we'll get those questions answered as soon as we can. I see a couple of questions starting to roll in, so keep them coming, and we'll get to those in just a moment.
All right, so first I think we'll do a quick tour around the building. So it's a really, really big building here, and inside of it we have 660,000 boxes. So these individual boxes behind me, and you can see on the other screen, Mel's going to take you on a little walk around the building. So those are all full of what we call core. So these are samples that we get from below the ground that we walk on, and they look like this. So inside of all those boxes are these little cylinder-shaped pieces of rock. And how we get those, oh boy, Mel's gonna open up a good one for us. See, so there's lots of those cylinders. So every single box that you see on that wall is filled up with cylinders of rocks like that. And so what we do is we go out, maybe in a farm field, maybe in the bottom of a quarry, and we set up something called a drill rig. So it's a really, really big truck. And what happens is we use these steel pipes and we push them into the ground. And at the end of that pipe is this kind of drill bit. So it has a big circle in the middle here, and that's how we get the core. So this guy goes down, 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 and the rock comes up, 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 up through that middle. And so what's happening is this is spinning and it's cutting out this nice piece of core for us. And then we can go down there, grab that core, bring it back, put it in a box here. And then all my geologist friends that I work with can study it. So around the state, we have about 2,000 points around the state. So each of those dots would be one core from the part of the ground you walk on down to maybe a few hundred feet, like 500 feet. Some of them go really far, like 2,000 feet. The deepest one we have is, I think, 3,000. Oh, and Mel's showing us that map right now. So all those little dots, if you can see them on the map, those are all in those boxes. And then, so I have kind of three main things that I'm in charge of. So the core is one of them. The next one is the cuttings. And those are these teeny, teeny, tiny pieces of rock. So instead of making a hole in the ground where we collect core, what we do is we chop the rock up into little bitty pieces. And we use a drill bit that looks kind of like this. So this guy goes down, down, down and drills. And what happens is these little gear heads, they have teeth. So these little pointy bits. You can imagine what would happen if you were a rock and this was spinning on you, spinning on you, spinning on you. He'd crush you up into little bits. And so what we can do is we can save those little bits, and they're actually really useful for some of the work we do. So all the water wells that Anna was talking about from around the state, we can look at these little vials that we keep on hand, and we can actually see what the rock looks like below the surface. So it gives us a good picture of kind of the rock we're looking at sandstone or limestone or granite, and it helps the people like Anna make better decisions on how much water those rocks can hold and how much water we can take out of the ground without affecting those around us and affecting the groundwater of the state. And so those we have, oh gosh, thousands, like 12,000. So all those points on the map, there would be 12,000 of them on the map. Yeah, this map is loaded up. And so you can see the dots kind of center in certain areas. So you can maybe pick out Madison, the capital of the state. So lots of people live there, right? So we need lots of water. Places with lots of population, so Madison, Milwaukee, Green Bay, those kind of areas are going to need a lot more water wells to give enough water to all the people that live there. So we have a lot of points from those places. Places up north, like you guys in Eagle River, I need some more points. Man, we got to do some more work up there. You guys have a lot of really interesting rocks there. They're granites and gneiss, and you have all those ancient volcanoes. So all that pink stuff on the map you see, those are all ancient volcanoes. It's pretty cool to study as a geologist. So these are, a billion years old at least. So that's billion with a B, and the Earth is about 4.6 billion. So 4.6 billion years ago, the Earth formed. And then about a billion years ago, all those pink rocks up there all got stuck onto North America and became Wisconsin. And then the kind of yellowy and green colors around in the southern part of the state, they make kind of a U shape. Those are all rocks that were deposited when there were oceans. So we actually used to be oceanfront property. And so that was about 500 million years ago to 300 million years ago. And then there's a big gap in time. And then we have the ice ages and all the glaciers. So they ground up all that sediment and left it around the state. And then some more time passed. And then here we are walking around on top of all those rocks. And so we know all of that. We're able to make all those decisions and know what's under our feet because of all of the stuff here. So it's pretty cool. So that's my job, is I kind of keep things organized and I help people access it and help researchers. They might want to come and study for their project. Maybe they're in school and they want to learn more about a specific kind of rock in a specific place in Wisconsin. So what Mel's showing you guys right now is from Calumet County. And these are about 100 feet to 600 feet below the ground surface. So these went pretty deep into the ground. And what it's looking at is a shale. So that's pretty cool.
Carson, this is really awesome. There's a bunch of questions coming in. Thank you so much for
Awesome.
all the information you've been able to share so far. In the video that Mel was holding the camera, we saw some other people maybe, or maybe it was you and Anna, I'm not sure,
That's
but
me and Anna.
some
Yeah.
of the questions were like, how many people, okay, I see it. How many people help you out in this place? And like, you guys both do this for your job. So what other kinds of, how many other people kind of work with you and get to do this kind of work as their job?
Yeah, that's a really good question. I pretty much am the only one who's in charge of all this specifically, but I get a lot of help from other people. I have students who help me, so they are students at the University of Wisconsin-Madison, and they come out and they'll help me put the rocks inside the boxes, take photos of the boxes, so we can get good pictures of the rocks for our research. I work with people who go outside a lot and they collect the rocks and they bring them back to me. So a lot of what I do is by myself, but it's because of other people doing a lot of the legwork for me. And Anna gets to go outside a lot. Maybe you can talk about what you do outside.
I do. Well, do you know how many full-time people do we have?
30?
But yeah, so we have about 30 full-time staff at the survey, and that includes Carson, it includes cartographers, it includes people who are studying the bedrock and the glacial materials and the groundwater, and all of those people work together to understand the geology and then communicate it to the people of Wisconsin so we can make better decisions about our resources. Yeah, was it?
What do you do when you go outside?
What do I do? Well,
Yeah.
oh, wow, that's a very good question. So I do a fair amount of field work, we call it. And what we usually do includes, or at least it starts with drilling wells, like Carson was talking about. Usually we drill wells with the rotary and create the cuttings. So like what Carson was describing with this. And we will use the geologic information from that, but we also will often put in, we'll do testing in the wells. So we'll put in something that measures the water level, and you can understand the water levels and how they change over time. And you can also do some really interesting things with lowering different pieces of equipment down the borehole. And as the cable kind of goes down and up in the hole, you can take different measurements of things like, oh, like we have a video camera. And so the camera will take a picture of the sides of the borehole. We also measure something, yeah, what other?
Temperature.
Yeah, temperature, fluid conductivity. So take temperature, for example. As you're going down the borehole, if you see a really big spike in the temperature, then that might mean that there's groundwater flowing in to the well at that point, or there's a change somehow in the lithology. And so we can use all of that data and bring it together to better understand how the groundwater system is flowing. But also we can use it to understand the chemistry. So that's another big piece of why the core is important, because if we understand something about the rocks, then we can understand something about maybe are there areas where we're more likely to see contaminants like arsenic that are not good for people to drink in really high quantities. I do another. Sometimes we put in much smaller wells. And so here's an example. If you can see it, I'm going to put it really close to the camera. It's not going to focus. If you look really closely, you can tell that there are tiny, tiny little slots in that screen. And so we put this in the ground, and we put it in like a sand and gravel, for instance. And the water can get in through these little slots in the screen. And that is a much easier way if there's a shallow water table for us to take measurements of the water. Yeah, in shallow environments.
Awesome. That's very cool. A couple of minutes ago, you had a rock kind of focused on the screen. It was this one. Yeah. There's some questions about that rock. What can you tell us about it?
You guys want to hold it?
Yeah, or you can talk.
Yeah. I mean,
Oh my gosh.
it's part of a quartz vein. Like,
Yeah.
so this rock has been outside for a long
Yeah.
time. You can see it has a good bit of moss on it. What's cool about this rock is all this white stuff. So that is a mineral called quartz. Makes up the majority of the Earth's crust, like some 60% of it or something. Um, it's a pretty cool, this is actually a pretty cool rock. So this is all quartz. What you see, so you can see it's kind of white here, and then it's kind of red or orange, pink in this other spot. And that is because it's iron stained. So it's all this, it's the same mineral, but that chemistry that Anna was talking about makes the rock change colors.
Thank you for that. Some students were asking if those long cores that you have all throughout the repository, are those hollow or are they solid? And how heavy would they be?
Yeah, so they come in a lot of different sizes. So this one is about 2 inches wide, and you can see, so it's a nice solid rock the whole way along, and I'll show you the other end. Okay, some of the boxes are really light. They're maybe 10 pounds. Some of the boxes are really heavy, and they're like 40 pounds. So they probably weigh as much as a fourth grader. I don't know how much do fourth graders weigh. Some of them are really heavy, right? Rocks can get really heavy. They would definitely be a lot lighter if they were hollow on the inside, but unfortunately they are not.
Awesome. That's really cool. Could we have another interesting question? Can you buy these cores of rock? Are they for sale?
They are not. So this collection's actually pretty cool. So all of our rocks are from the state of Wisconsin. I don't take any rocks from Iowa or Michigan or Canada, right? And so what we do as geologists is we ask, we do something, we write grants. And so basically we come up with a really good scientific idea, and then we ask for money to pursue the study of that idea. We try to figure out the answer to that question. And so what we do is we get this grant money and we pay for a driller to come and collect these samples for us. And so we paid a lot of money for these. So these are the cores that Mel is showing you are probably $130 just to collect 1 foot of that core. And what you see in that box is 10 feet multiplied by probably 80 boxes on the table. So we spent a lot of money collecting these core. And the whole purpose of us having this library is because we spent so much money collecting these, we don't want to collect them for one project and throw them out. That'd be really wasteful, right? What we can do is we can keep them and we can study them for our project, and we can actually use them again later. So these rocks are, this core specifically was drilled maybe in 2003 or 2005, and it was used for a project in Manitowoc County. And then we are now in what, 2025, and we're using it again for a project in Calumet County. And so we saved, hundreds of thousands of dollars being able to reuse this core. And instead of re-drilling this exact core, we can drill a different core in another area. And so we can kind of firm up our geologic interpretations, because the more data we get, all the better our model is going to get. So no, we can't, you guys can't buy them.
That's cool that you could use them for lots of different projects and purposes. That's really interesting. The rock that's on the screen right now, there's a question about like, why is it kind of white and gray and not more like just a homogeneous gray color or something?
Yeah, that's a good question. So this is mostly a shale, and those white spots you're seeing, this is actually pretty neat. Those are teeny tiny bits of shells. So what happened was, this is representing the bottom of the ocean floor. And if you ever walk into a lake and you kind of walk in, it's mucky and it makes that like, ooh, like in between your toes. That's what the gray part would feel like if it was still being deposited. And then all these little white pieces are teeny tiny bits of shell. So when you are walking into maybe Lake Michigan on the beach, there's sand, and then you walk along and there might be a line of shells. That's kind of what those are representing. And then if you kept walking into the water, it would get into more of the gray part. And so these are shells that are probably 400 million years old, I would guess. And a lot of them are something called a crinoid. If you've ever heard of or seen a sea lily, they kind of look like that. Another shell that's really prominent in there is something we call a brachiopod. And that looks kind of like a standard seashell you would see at the beach, but they're really old.
Awesome. That's really interesting. What's the most, I mean, you talked about like, we can't buy these because they're valuable for research and for different projects. But there's a couple of questions. One, what is the most valuable thing that you found in one of these cores? Have you ever found gold? And yeah, maybe we'll start with that one, then we'll come back to the next question.
Okay, so the gold one, we do sometimes, some of our collection gets donated by mining companies. So when they're done with their studies, and since it costs so much to get that core, and we can still study it, they'll donate the cores to us. But first they take out all the gold because they want the gold. So unfortunately, we don't have any gold here. I would say the most valuable specimens we have are the samples right behind me in these metal trays. These are actually really cool collection. They were donated by a mining company that worked a lot in the northern part of Wisconsin, kind of Ashland, Bayfield, Douglas area. And these represent some of the oldest rocks we have in Wisconsin. These are almost 2 billion years old. And what they represent is a failed continental rift. And so all that red sandstone is sand that was made when the continent tried to pull itself apart. And so there's lots of erosion going on, and that sand gets deposited and lithified, and then we can study it. And we call it the mid-continent rift because it's located in kind of the middle of the continent. And what's really cool about it is when you have when you have plates try to pull apart, is it becomes like this kind of a big hole in the ground. And that's actually how we have the Great Lakes. They're all because of this mid-continent rift. So they kind of pulled apart, made these big holes, the holes filled up with water, and now we have these big, really great freshwater lakes.
That's really cool. Thank you. Um, so there's been a request to meet Mel, the camera person. And we're wondering if we can see Mel.
Who's the lady
Yeah.
behind the camera?
Yeah, there she is. That's awesome. Thank you. And then we were talking a lot about some of the valuable minerals and stuff that you found. And a question came in that is like, are there any jewels or gems like rubies or emeralds or anything like that that you found?
I would say if we had any, they would be teeny, 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 tiny, like the size of a grain of sand. Um, I don't know that those are really all that common in Wisconsin. Do you guys know?
No, there's some garnet, or like in some like corundum that wouldn't be a gem. Because isn't that some of what they mine in like North Central for like roofing?
Abrasive.
Yeah, abrasive stuff. There's some mining in Wisconsin to find really hard minerals for like sandpaper. Um, and that would be the same mineral as rubies and sapphires, but we call them rubies and sapphires when they're like pretty in certain colors. The kind of like dull ones, right? You can find more often here. There's some pretty garnets up north though.
You mentioned that some of these cores can be repurposed for different projects. So what is a project? What are some of the projects that you usually work on a typical day? And then who is requesting those projects from you?
Yeah, that's a really good question. So I would say the main product that we produce is maps. So we make a lot of maps. Sometimes we're mapping the rocks that we see on the surface. Sometimes we're mapping the rocks that we can't see below the surface, but we use all of the materials here to make inferences on what we see. And then sometimes we make different varieties of maps of water. So maybe we map where the water table is, or we map instances of springs around the state. So a lot of maps, right? So one map might be a project, and our geologists might work on that project for 1 year. They might work on it for 4 years. It depends on how big of an area they're mapping. So a pretty standard project that we work on is we will decide on one county in the state and we'll map that county. That kind of project might take a geologist 4 years to do, maybe 5, depending. And what they do is they'll go out and they'll look at all the rocks they can. So if there's rocks at the surface, we can walk around and see. They'll go out and make notes on what they see, write down what they see, plot it on the map. They might take samples and we can send those in to do chemistry and look at chemical analyses on those samples and kind of fix our understanding of the rocks that way. And then they will hand over all that information to one of our cartographers. So that's a fancy word for someone who makes a map. And those guys will make the map look really pretty. They choose all the colors and they put all the labels on the map to make sure you know which river that is and which rock type that is. And so working together, there might be, gosh, 3 or 4 or 5 people involved in making one map. So doing one project might be a lot of people. And then what we can do is once we have that map, people who work for the county or even people who work for the city, people who do consulting, like what Anna was talking about earlier, maybe the Department of Transportation wants to build a new road and they need to know, okay, where's the rocks and what kind of dynamite are we going to need to be able to blow up really hard rocks? Maybe someone is trying to put a new deck on their house and they're like, man, the ground's really hard. I wonder if I'm really close to the bedrock. Like, how far below the ground does it turn into that really hard rock? We can answer all those questions from that map we made. So they actually are really important, and we usually do them at the county scale. Sometimes we do them at a little bit of a smaller scale, but a lot of times we're mapping the county and we're doing either kind of the bedrock, so that hard rock below the surface. We're doing kind of the sediment and soil on top of the ground, maybe down to 100 feet. And then sometimes it's a lot more kind of water table, looking at water resources. How long does a water project take? Also maybe 4 or 5 years?
Oh, yeah, it depends on the project. At least 1 year, usually several.
Cool. I didn't know that, so that's all really interesting. Those are really long projects. It sounds like
Yes.
there's a lot of information that is in each one of them. One of the questions that came in was, can you do the drilling and collect cores in the winter or only when it's not frozen?
That's a really good question. You can sometimes. It's usually not a problem of the ground being frozen. Sometimes it is for that kind of first 100 feet in the looser sediment, but for the bedrock, for that hard rock under the ground, you can drill that. It's usually more of a problem with the machine that we use. So there's a lot of fluids that have to go in to lubricate everything, and in the winter, some of those fluids might freeze.
Yeah, also the same thing for doing any sort of water testing. You know, we can get out there, we can put the pump down into the water well, but it is really not fun to work with pipes and tubing when it's below freezing. The water just freezes and you can't do it. So that's one reason why it takes so long for us to do a project, is almost all projects involve some sort of field data collection. And if you're doing that for, 6 to 9 months out of the year, and then you do the analysis and actually make the map or whatever the product is.
Yeah, a lot of the winter, the geologists will come here to this building and they'll study all of the rocks that we have that are, in or close to their area that they're working on.
Well, you mentioned coming into the building, and one of the questions was, where is the building?
It's very mysterious. So we are in Mount Horeb, Wisconsin. We are about 30 minutes west of Madison.
Fantastic.
Yeah,
Um,
we also have an office too. So our office is in Madison. So sometimes we're here and sometimes we're in the office at, working on a computer.
Depends if you need a rock
That's
or a
right.
computer. Yeah, okay. This question asks a little bit about, it gets to kind of what it's like to be a geologist. How often do you get to have a meal at work? Like, can you take a break, or just a little break at lunchtime? Or, like I'm sitting in a lab where I'm not allowed to eat in the lab that I'm in. So are there any rules around that?
Yeah, so this building, it kind of has the same rules that you would at a museum, right? So a lot of stuff you can't touch. And at the museum, you can't have drinks, you can't have food. We kind of have that rule here. You might see me drinking water. That's okay because water is easy to clean up. What might happen is we might get pests, and we don't want, mice or bugs. We don't want them crawling around because I might scream and go, ew. But also we don't want them to chew through our materials, right? So a lot of stuff here is stored in cardboard or paper boxes. So it's mostly just to keep our collection safe. But if I am a standard day of work, I usually snack a lot throughout the day. So if I am sitting at my desk at our main office where I can eat, I usually have a snack around 11, and then I have my lunch around 1, and I usually have another snack before I go home, maybe around 4.
Being in Mount Horeb, it's an excuse to go out to lunch and then come back to the building.
Yeah.
Yeah. And then like how many hours in a day do you work? Like 6, 7, or 8?
I would say I usually work about 7 to 8 hours. Sometimes it's a lot longer, especially if we go outside, if we're working in the field, just because it might take time to drive back to the office, and because it takes a lot of planning and a lot of time and energy to get out into the field and do what we do. So sometimes we want to stay out there as long as we can. So in the winter, we will stay out as long as the sun is shining. It's hard to look at rocks in the dark.
That makes sense. This question asks, how much money or value is the entire facility and all the cores worth? Like if you had to insure it, it's like irreplaceable, right? Because there's so much data and cool things there. But if you had to put a number on it, what would it be valued at?
Yep, it is close to $200 million.
Wow, that's a lot.
It is many.
Yeah. There's a question about like near the staircase, kind of at the beginning of the call when Mel was walking around. There was some tape there, and one of the students is curious what that tape was all about.
Like measuring tape or tape?
So maybe we can go take a look at that. And while we're looking for that, how many total rocks or types of rocks do you, oh, maybe is it maybe the duct tape? Okay. Could be that. I'm not sure. Yeah. Oh, the duct tape. Okay. What would you use the duct tape for in this kind of project?
Usually just for fixing stuff. So sometimes the cardboard box, you get box from Amazon, and sometimes it's kind of smushed in. That happens sometimes around here, and I have to tape it back up.
Okay, cool. I'm glad we solved that. How many rocks do you think you have found? Or how many types of rocks are there in your facility?
Oh,
If either of
man.
those are answerable.
We probably got all the types. We have all the sedimentary kind, all the igneous kind, and all the metamorphic kinds.
Cool. And maybe each of you could answer this one. Just thinking about like, why did you decide to go into this career?
Do you want to go first?
Sure. For me, it was it was lots of little decisions as as I started my career, where I started out in consulting and I was doing it was called geotechnical engineering, and it was mostly what I would do. So is there would be someone who wanted to build a building, and I would go out and help make sure that the foundation or the bottom of the building was stable enough for them to build on. And so I would be out on construction sites and measuring the density basically of the ground. And it was really interesting, but I knew it wasn't quite what I wanted to do. And so I kind of took that and said, okay, well, what if I did something with water? Because I did a couple of projects while I was doing that in the engineering firm that were about flooding, and then there was one about groundwater levels. And I thought, okay, well, what if I ran with that? And so I reached out to actually a bunch of people that I knew worked in water. I just Googled them. All right. And I sent them an email and said, hey, can I buy you coffee and you tell me what you do? And they told me, and through that, I figured out, oh, well, I like what this person was talking about. Maybe I want to try that. And so I called that person and I said, hey, do you know anyone who's hiring? And they said, yeah, I think I do. And so I found someone who was doing water resources, and I applied for a job there. And so at each step, I kind of found things that I liked, and I tried to make my way toward that piece of it. And the things that I knew that I really liked was, partly I really like the technical aspect specifically of groundwater. It's just a really interesting thing to study. I really like that it's applied. It helps people make real decisions in real life. And I like that it's a combination of doing work on a computer where I'm looking up data and kind of thinking about it, and working outside, because I love being outside, and being able to combine the two of those is something that I really enjoy.
Mel, you want to talk about caves?
Yeah. Yeah. Yeah, I came to geology in undergrad, because it was an interesting science class, but I was an English major. And I think that I was drawn to geology after avoiding science because it's so observable, right? It affects so much of our lives, and even just decisions you make as an adult about where you live, how you vote, like the decisions you make in your life, why the weather happens, right? It's all part of the Earth system. And then, rocks tell stories. I've always loved, I started working at the Geology Museum in Madison right when I started my geology major. And it was so hard for me to focus to some extent because I love just all of these like tidbits and like stories about the deep past that are just like fascinating, even just in Wisconsin. And I wanted to know more. And then I also really wanted to be outside. So all my background is in glacial geology and past climate study. So I've got to go to the Arctic several times and do like dramatic, like gritty field work. And now I work in caves, so I get to kind of once again have that kind of intense field experience. Then you come back and get to think about all the observations that you've made. And yeah, lifelong curiosity. And then my position at the survey is the outreach and communications person. So I sort of early on knew that there was this unicorn job that's hard to find, where I get to do geology and then also get to talk to people about it all the time.
Yeah, I would say I'm kind of similar to Mel. I, kind of did this one thing and I was like, wow, that's pretty fun. Maybe I can find a very, very specific one-of-a-kind job where I do that thing. So in undergrad, I worked for a professor who studied sedimentary rocks, and he was a really, really lovely guy, and he was very energetic, and he got me really excited about sedimentary rocks. So I decided to go to grad school and study some more sedimentary rocks. And I think maybe during my first year of grad school, I decided, man, I really like this process where you kind of you do the scientific method, right? You get these samples, you work on them, you have a hypothesis, you do a bunch of research, and then you write a big report, and then you get to tell people about it. And I said, all right, I gotta find a job where I get to do all those things, and I get to go outside. And I worked for the person who has my job, but in the Iowa version for a summer, and I got to observe this job, and I was like, yeah, man, that's the job I want. And it was really just really lucky that I applied to my position and I got it. And so I really like what I do. I really like to get to um, I'm really naturally curious. I always want to know how something works, and being able to get to see how the earth works from looking at all these rocks is really cool. And it just, I don't know, it just really tickles my brain.
I would
That's
say
fantastic.
that I feel like getting experience in undergraduate and early on, and like finding experience to test out, right? Like what you like is
Mhm.
something that I think all of us talked about in some way or another.
Yeah.
Like
Mhm.
learning how science actually works, to see if you like it or what parts of it you like.
Yeah, and another theme that kept kind of coming through in your stories was like, I liked this part, but not this part. How can I do more of that part that I liked? And there's so much of sometimes you don't even know the job you're moving in the direction of. You're just trying to find the next thing that has a little bit more of the thing you enjoy the most. That's
Mhm.
awesome.
I will say also, we all three of us talked a lot about liking to work outside. But there are a lot of hydrogeologists that
Yes.
don't work outside at all. They are only, and then there are some that are almost exclusively outside. So there are lots of unicorn jobs like they're talking about, but there's also a big variety of things you can do within the geology field if you like one thing versus another.
Yeah, a lot of geologists, they only work in like a traditional lab, like where you saw Val sitting. They work in a lab with, beakers and liquids and stuff.
Some are modelers, right? So
Yep.
kind of climate modelers, for instance, right, are working on computers, right?
Yeah. That's awesome. Well, we are just about out of time, but audience, I want to thank you for all of your wonderful questions. That was really interesting to see what kind of questions you had and to listen to the answers that Carsyn, Anna, and Mel were able to give us. I'll end with one final question. Can each of you share what your favorite rock is as we wrap up the call?
I was hoping it would be the I don't need time to think. My favorite rock is sandstone because all those individual grains of sand are pieces of all the other rocks. So technically, if I like sandstone, I like all the rocks.
Oh.
So hard. What's your favorite rock, Anna?
Oh,
I'm thinking-
so
I think I'll
so
start mine.
yeah, so my favorite rock, I would say, and this is maybe a little bit of a cop out, any sort of crystalline rock. So so like basalt or granite, they're kind of so like here's an example of one here. And I love them mostly for their form. So if you're walking around and if you have shallow bedrock and you have this like big outcrop of rock, especially granite where it's sort of like a big mound, I just find that very satisfying to I don't know if
I just
I
like
just like it. It does not make a very good aquifer, so it's not my favorite aquifer rock, but yeah, I like the shape of it.
I went and found mine.
Oh boy.
Yeah. I like green sandstone. So
Ooh.
there's a special sandstone that's in Wisconsin that has a mineral called glauconite, which is green. And so you have these beautiful rocks like the one I'm in the frame that have like normal buff colored sand, like you see all over the driftless area of Wisconsin. And then you also have green sand. And I feel like it just makes you can see those like kind of patterns in this rock are ancient ripple marks. And so you have the green sand, you can see the ripple marks. I'm a sedimentary girl because you can see all these past environments and
Yeah.
fossils. Like, come on. Yeah, we love a sandstone. Good. Mhm.
That's awesome. Well, thank you so much for all of your time today. I learned so much. It was really cool to have you do the tour from the core repository. I've never seen that space before, so that was really awesome. Thank you, everybody who joined the call, and keep being curious, everybody. Thanks so much.
Thanks,
Thank
guys.
you.